what is the purpose of graph? This is to show the numerical facts. And when you have simply numbers, we will not be able to understand it better. But if we have in numerical form something that is presented in a way of visual representation, then we understand it quickly, easily and clearly. So this graph actually are the visual representation of data being collected, and you can also present it in the form of a table, but the graphical presentation is always good. The informal way of putting the numbers, first way. Second is the tabular form, rows and column. And then third is the picture form, like this. Right? This is 1, this is 2. So you can compare them. So particular when we are treating with the trend or comparison, this becomes very important. So we have already seen some type of graphs. Let us recall them. First is bar graphs. So what is a bar graph? Bar graphs show comparison between categories, and it may contain two or more parallel vertical, you can say a horizontal or vertical bars, right? So we have two axes. This is the horizontal axis, this is the vertical axis. In this case, in this particular graph, Anu mathematics marks in 3 terminal exam is been shown. First terminal exam, she got how many marks? She secured 25, then she secured 30, and then in the third terminal, she secured third marks. In the third, she secured around 45. So there is a gradual increase in the marks. First of all, she has improved the performance, and these are the pillars, you can say pillars or graph, in the form of graph. These are the bars, just like you eat chocolate, there are bars. This is like a bar. Bar graphs can have double bars also, not a single, and in fact they can have multiple bars. So if you want to compare, say, account of sales of various fruits over 2 days period, then you can say Monday or Tuesday. You can always show it like this. This horizontal axis now has sales, how many sale was, or how much sale was done in terms of kg, and these are the different these are fruits. So in mango, it was around 15, you can say this is around 17.5. So this is 17.5 kg was sold on Monday, and on Tuesday the same mango, it was sold, see, 22.5 kg, right? Similarly, let us take an example of papaya. So Monday and Tuesday, the sale were same. There were not a single change, and those selling or the sale is at par. Pie graph or a circle graph. Now pie graph is very important when it comes to compare parts of a whole. So you have a whole, say this is the whole. Now you want to show this part, this part, this part. So in fact, showing this is a way, and another showing is in the form of a circle. Circle represents the whole, means complete 360 degree. And this is a pie graph, because circle comes from pi. 2 pi r is the circumference, pi r square is the area. So pie graph is very important, and this is an example pie chart or pie graph or circle graph. It is showing the percentage of views watching different types of viewers watching different types of TV channels. So 15% of them watch news. Most of them are interested in entertainment, and least 10% they watch or they view the informative channels. Histogram is again a bar graph, is presented as a bar graph that will show the interval. Histogram is actually the frequency representation, frequency distribution graph, you can say, or representation. So it will have adjacent bars over the interval. So this is the data which we have, and we'll see that the distribution of weight in kg of 40% of a locality. So if 40 to 45 weight, the number of percent are 4. The weight from 55 to 60, they are 6, likewise. So how to show this? See, we are not starting with 0, so we have to give a king. You can say a jagged line or a broken line. So we start with 40, and we say from 40 to 45, 4 people were there, and from 50 to 55, there were around 13, right? So just see this, there is a jag line again, let me remind you, and this jag line has been used along horizontal line just in order to show that we are starting with 40, because we don't have any data between 0 to 40. And see, there is no gap. Why there are no gap between the bars? Because the intervals have no gap. See, after 45, 45 comes. So 40 to 45, then 45 to 50. So there is no gap between the intervals. So there will be no gap between the bars also. A line graph. Line graph will display what? It will display the data that change continuously over a period of time. So we have certain points, you can say like this, and we join them. So we have different points and we join them. Let us take an example. Renu, she fell sick. Her doctor maintained a record of her body temperature every 4 hours. So it was in the form of a graph. So this is called a time temperature graph. It is a pictorial representation of this data. So we'll see just the data. In this horizontal line, or we call it as an x-axis, we'll use it to show the timings at which the temperature were recorded. So these are the time on the horizontal axis. And on the vertical axis, we'll try to show the temperature. That is the y-axis. So this at 6 a.m. the temperature was 37. So we just took this 37 and 6 and the line wherever it is intersecting, we place a point. And similarly for 10, 2 and 6, and we join them. This joining, this is the line graph. So each piece of data is shown by a point here, point on, if you want to use a square grid, it will be very good. Then the points are they are connected. They are actually connected by line segment, and the result is the line graph. Now what these graphs tell you? There are so many things which you can say get out or perceive from this graph. For example, you can see the pattern, most at 10 a.m. and then decreasing till 6 a.m. and also there is a decrease of 3 degrees between 6 a.m. to 10 a.m. 6 to 10 increase, sorry, there is an increase. So there is an increase, 37 to 40, so there is an increase. There is an increase and there is a decrease also. And see, at 8 a.m. no recording of temperature was done, right? Now, after this, at 8 a.m. there is no recording, but we can, by just joining this point, we can find out that this will be around 38.5. So we can know, we are in a position to know the intermediary points also, intermediary temperatures also. If we want to show a graph on performance, see, we have a graph. I'll just show you the graph, and it is representing the total numbers scored by two batsmen A and B during 10 different matches in 2007. And we have to study the graph and we have to answer these questions like what information is given on the two axes, which line shows the runs scored by batsman A, were the runs scored by them same in any match in 2007, if so which match, among two batsmen who is steadier, and how do you judge it? Let us see first of all the graph. So the horizontal axis shows the matches, 10 matches are there, and the vertical axis, that is the y-axis, is showing the run score. So batsman A is shown by the dotted line, batsman B is shown by the dark line, means this is you can say a broken line or dotted line, or you can say this is a standard line, right? Now here, this gentleman or this batsman A, sometimes he scores 20, sometimes he scores just 0, 2 times he has scored 0, but the second batsman, first time he scored 60, then went to 40, then 60, so he has, the lowest is 35, but the highest is also good, 100. So he is steadier because he is not, if you take the flow of this graph, he is quite steadier, but this guy, sometimes he scored 115, sometimes he just get out at 0. So let us now answer these. First of all, the horizontal axis indicates the match played during the year. The vertical axis show the total runs scored in each match. The dotted line, this shows the batsman A. And the fourth match, see, this is the fourth match. At this point, they both have same vertex, you can say. Both have same point. So in the fourth match, both have scored 60 runs. This is the 60. So 60 runs they have scored. Now, as I just suggested, batsman A has one great peak but many deep valleys. He does not appear to be consistent. But B, on the other hand, has never scored below 40 runs. And the highest score is 100 as compared to A scoring 115 one times. A has scored 0 in 2 matches, right? And most of the time he's scoring less. Sometimes he's scoring higher. So he is inconsistent or not very reliable. But this guy, the way he has been scoring the runs, we can say that at least he is going to score 40, not less than that. We have another graph which describes the distance of a car from a city P at different times, which is traveling from city P to city Q, which are 350 kilometers apart. Now we have to answer these. What information is given in 2 axes? From where and when did the car begin the journey? How far did the car go in the first hour? How far did the car go during second hour, third hour? What was the speed? His speed was this way. Sometime it was means it was not moving, or you can say what was the speed same during the first 3 hours, and how do you know it? Let us answer these. Did the car stop at any duration? We'll see about that. And when did the car reach city Q? First of all, this car is not starting at 0 point because it is starting at 8. So we have first answer as 8 it is starting, and at 2 p.m. it is reaching the point Q. Now at first hour it has gone to a distance of 50. So this, from this point to this point, it is 50. Second hour it went from 50 to 150, that is 150 minus 50. So 100 kilometer it went. Then it went from 150 to 200, so it went 50 kilometers more. At this point, means from 11 to 12, the car may be resting, or the guy may be having some lunch, etc. So this car is not moving here. So now you can answer each and every question. First of all, the horizontal axis is showing the time, the vertical axis is showing the distance. The car started at 8 a.m. The car traveled 50 at first hour, then 150 at the second hour, like this. So at 8 a.m. it has just started from the city. At 9 p.m. It went up to 58 kilometer. So during 1 hour, 8 to 9, it traveled 50 kilometers. But at the second hour, from 50 to 100 it traveled. So 150 it traveled. So it traveled 100. Why? Because 50 it has already traveled and 150 it traveled. So we just subtract. This is 100. The third hour, from 150 it went up to 200. So 200 minus 150 is 50 kilometer. For the third hour, 10 to 11, it went or it ran for 50 kilometer. Now the speed of the car was not same at all the time, because at 8 to 9 it was different, and 9 to 10 it was different. The distance traveled is different. And then at when it was at 200 kilometer, from 11 to 12 it didn't move. It was only at 200 kilometers. That means at this time that the car was not traveling, and at 2 p.m. it reached the city Q.